Hi everyone, this video is going to just walk through some word problems from the book. So we're just going to do those completely. So the very first problem is number 1. Express the area of a 30, 60, 90 degree triangle as a function of the length h of the hypotenuse. So we're looking for the area as a function of h. So just so that we know that, I'm going to write a of h is going to equal some equation. So that's what we're looking for. To start, the only thing that we're given is that we have a 30, 60, 90 degree triangle. And we know that this is the hypotenuse. The special thing about a 30, 60, 90 is that this is really half of an equilateral triangle. So this side right here is one side length of the equilateral triangle, and it's cut in half, meaning this base is going to be the hypotenuse, or the side length, divided by 2. So that's a little information about our triangle, our setup, that we just need to know. But we're looking for the area of a triangle, and the area of a triangle is just 1/2 base times height. So notice I have an h here, this represents height, this h here represents the hypotenuse. So if we want to find the area, we're looking for the base of our triangle, which is right here, times the height of our triangle. And our height of our triangle is over here. So we don't know that yet. We need to figure out what that height is. And to do that, we're going to use the relationship of this triangle. So we can think about the Pythagorean theorem, which says a squared plus b squared equals c squared. Well, my a, I'm going to say, is h over 2, and that's squared, plus my other side length, which I don't know, I'm just going to continue leaving that as b squared, equals my hypotenuse squared, which is h squared. So I'm looking for whatever this b value is. So to do that, I'm going to subtract this side length over. So I'm going to have b squared equals h squared minus h over 2 squared. And then I'm going to square root. So b equals the square root of h squared minus h over 2 squared. Simplifying this a little bit, we have h squared minus h over 2 times h over 2 is h squared over 4. We can then rewrite that as 4h squared over 4, getting that common denominator, minusing h squared over 4. And when we do that, we see that b is equal to the square root of 4h squared minus 1h squared, which is 3h squared, all over 4. Because this is all being multiplied together and being divided, we can take the square root of the numerator and take the square root of the denominator. When we do that, the h squared just becomes an h. The 4 in the denominator, the square root of 4 is 2, and we can't really take the square root of 3, so we're just going to leave that right there. So this b value, this side length, is really h over 2 times the square root of 3. So h over 2 times the square root of 3. We can now put all these values into our formula because we have them all. So area equals 1/2 our base, which is h over 2, times our height, which is h over 2 times the square root of 3. And when we combine everything together, we have 1 times h, which is h squared, all over 2 times 2 times 2, which is really 8 times the square root of 3. So the area as a function of h is right here, because area is all in terms of this h. Okay. Next one. The height of a cylinder is twice the diameter. Express the total surface area as a function of the height. So surface area as a function of the height. So surface area has to be in terms of height somehow. And how do we actually find surface area of a cylinder? A cylinder, you have to find whatever the area of our bases are, plus whatever the area of the sides of our container are. So let's work with what's easiest, which is the bases. The bases are circles, so we know that that's going to be pi r squared. And because there's two of them, I'm going to write 2 pi r squared. This must be added to whatever the side of our cylinder is, whatever the area of that side is. Well, when you unroll a cylinder, it's just going to look like a rectangle. It's going to look like a rectangle like this, where you have the height, and then this is really what goes around the circle. And what is around the circle, the distance around the circle, is the circumference. So to get this side piece, we're going to take the height times the circumference. So the height is 2d, and the circumference is really 2 pi r. All right, so let me just write that out there. 2d is actually the height, and then the pi r squared is really the width or the circumference of our circle. And then this is really just the area of the circle. Okay. All right, but we need everything in terms of h, so that's a problem right now because we have it in terms of r's and also diameters. So radius and diameter. We need to get it all consistent. Well, we could just say that this diameter right here, this height of 2d, that's really, if we think about it, diameter is equal to 2 radii. So if we have 2 diameter, that's really just 4 radii. So now I have everything in terms of r, but I need it in terms of h. So what does h equal? H is the height of our cylinder. We also know the height of our cylinder is twice the diameter. And we know twice the diameter is really 4r. So the height is really 4 times the radius. So if I want to get rid of all my radii in my equation, I need to find whatever the radius is in terms of r. So if I divide the 4 over, my radius is in terms of h. So everywhere I see an r, I'm going to substitute in what I know r is. It's h over 4. So let's do that now. So area equals 2 pi r squared, so it's h over 4 squared plus 4 h over 4 times 2 pi r. R is h over 4. Simplify this. So we have 2 pi. H over 4 squared is really h squared over 16 plus 4 times h over 4. These 4's really cancel, so there's just an h there. And here we have 2 pi h over 4. This 2 can reduce with this 4 to be pi h over 2. All right, continue to simplify. This 2 can reduce with this 16, so we have 1 and an 8. So pi h squared over 8 plus h times pi h is pi h squared over 2. And if we find a common denominator here, which would be 8, let's go over here. This is really, we're going to keep the area. We're going to keep pi h squared over 8 because 8's our common denominator. To get a common denominator of 8 over here, we have to multiply the top and bottom by 4. So we really have plus pi h squared over 8. Adding those two numerators together now, we have 5 pi h squared over 8. And that is our area equation as a function of the height, because everything in there is in terms of h. Okay? Let's move on to number 9. Number 9 says that a light 3 meters above the ground causes a boy 1.8 meters tall to cast a shadow s meters long, measured along the ground. So as shown to the right. So we have a 3-meter pole right here. So the pole is 3 meters. We have a boy that is 1.8 meters tall. So he's right here. That casts a shadow S meters long. So S meters long, the boy's shadow is right there. We want to express a function S as a function of D. So we're looking for S of D. What does that equal? Which is the boy's distance in meters from the light. So we're looking for this value right here. So if we're given this distance, what is his shadow length going to be? That is what the question is really asking. Well, we can think about this as a couple of different triangles that are congruent to each other. That are similar to each other. Here we have one triangle that has the same angle. So this triangle has the relationship of 1.8 and S. That ratio, since these triangles are similar, that small purple one to the big orange one, should have the same ratio as 3 to its bottom base. So let's just write that out right now. So we're saying, hopefully you all could see that written out there. So just look at that again as we were talking. We have a light 3 meters above the ground, causes the boy 1.8 meters tall to cast a shadow S meters long, measured along the ground as shown to the right. So sorry if that was a little obscured for you. Alright, so we're saying that this ratio of 1.8 to the bottom of the triangle should be the same thing as the height of this triangle to the bottom of the triangle. So the purple triangle ratio should be the same as the orange triangle ratio, which is 3 over the base. And this base is D plus S. Okay? So if we simplify that a little bit, I want to get rid of my fractions, so I'm going to multiply the S to the other side. And I'm going to multiply the D plus S to the other side. So I have 18, oops, I didn't want purple. 18 D plus S equals S times 3. That's just 3S. Distribute the 1.8 all the way through, so we have 1.8D plus 1.8S equals 3S. Now we want to find out what S equals, because that's what our equation is asking for, S in terms of D. So I'm going to subtract this 1.8S to the other side. I'm going to do that up over here. So 1.8D is going to equal 3 minus 1.8, which is 1.2 times S. And I want S alone, so I'm going to divide both sides by 1.2. And when I do that, I end up with 1.5 D equals S. Now, is that what we were asked to find? Yes, we were asked to find S in terms of D. So the shadow length is in terms of the distance from the light pole. So that is all we're asked to find. So we are done. So when you're seeing things with triangles or cones, the best way to solve those, if you do not know a lot of the lengths, is look at similar triangles. So in this case, we were looking at the ratio of the height to the base compared to the ratio of this triangle's height to this triangle's base. So that's just the rule for those. Okay. Number 11, a box with a square base has a surface area, including the top, of 3 meters squared. Express the volume of the box as a function of the width, W, of the base. So we want volume as a function of W. What does that equal? Well, a box with a square base. So if we said the width of the base was W, and it's a square base, that means the height is also going to be W. Just to fill that in. We do not know how tall the box is. So, what we want to do now is just write down what we know. We want to find volume, so let's just get the volume equation out there. Alright, so volume equals our base times our height. The area of our base is W times W. oops, I'm sorry, we're looking for a we're looking for a volume, but we know a surface area of 3. So let's continue on this track, but I was thinking about it differently, so I apologize. Still, everything's the same. We're still looking for volume as a function of W. The volume of our box is our base area, which I'm just going to say is big B, times our height. So our area of our base is really just W squared times whatever our height is. I don't know what that is yet. So that's as far as I can go because I need to figure out what H is, but I have no idea. So I'm going to go back to what else I know. I know the surface area is 3 meters squared, so I'm just going to write out the surface area equation for this. So surface area is the area of all the surfaces. So let's just count out what we all have. We have a base here, that's W times W, and then also that same base up here. So we have two surfaces whose areas are W squared. We also have all of these sides, and there's a total of 4 of them here, and then the one in front. So how do we find the area of those sides? So, oops, maybe I should say we're finding 4 of them. We find the area of those sides by the base times the height. And we don't really know what the height is, so we're just going to call it H. But each one of those is W times H. Maybe I should have done that in orange. W times H. Okay. Well, the other thing we know is that the surface area is really 3. So with that being said, we can rewrite all this. And if I distribute the 4 through, it's just WH. And now we want to see if we can use this to find H, because we want to plug H in right there. So let's try to see if we can find H. It looks like each of these terms have a W in common and also a 2, so I'm going to pull out a 2W. So from the first term I'm left with just a W, and the second term I'm left with, the W's gone, divide the 4 by 2, so I'm left with 2H. Okay, and remember, my goal is just to find something in terms of H. So I want to get everything away from H. With that being said, I'm going to divide by 2W. So 3 divided by 2W, which equals W plus 2H. Still looking for H, so I can subtract this W away. So 3 over 2W minus W equals 2H. That doesn't look too pretty, especially when I know I'm going to divide by 2 here. So I'm going to just rewrite it as a fraction, a single fraction. So with this, I need a common denominator of 2 over W. Right now, this W is over 1. So I'm going to rewrite this as 3 over 2W. And I need to multiply top and bottom by 2W to get this fraction the same denominator. So if I multiply it on the top, I'm going to have 2W squared over 2W is equal to 2H. Oops, that did not look right. 2H. Okay. And then I'm going to backtrack a little over here just so I have more room. Combining the 3 and the negative 2W squared, I have 3 minus 2W squared all over 2W, which equals 2H. Divide this 2 over to the other side, which really, you can think about it as we're multiplying by 1/2 to each side. So that means I'm going to have 3 over 2W squared over 2 times 2W is 4W, and then I'm left with just H. So I can put this H back into my volume equation because that's what I wanted originally, and then I will have what I want. So W squared times 3 minus 2W squared all over 4W. It's all being multiplied. Since this is all being multiplied, this W squared can reduce with that W in the denominator. So we have W times 3 minus 2W squared over 4, and then we can distribute this W all the way through. So looks like I ran out of a little bit of room again, so I'm going to go back up here. Distributing that W through, my volume is going to equal 3w minus 6w squared, oops, just kidding, minus 2w squared all over 4, oops, w cubed. So 3w minus 2w cubed all over 4. That is volume in terms of w, because that's the only variable there. That's what we sought, so that is our answer. Whew. Notice that these problems require a lot of space, and every single one we drew a picture with them, so make sure you're doing that as well. Okay, moving on to the next one. We have a cylinder, a cylindrical can, that has a volume of 400 pi cubic centimeters. The material for the top and the bottom costs 2 cents per square centimeter, and the material for the vertical surface costs 1 cent per square centimeter. So let's just look at that. So 2 cents per square centimeter for the top and bottom. So this top and the bottom, they cost 2 cents for every square centimeter. And this surface part in the blue, that costs $1. Okay, so I should write that in blue. But how do we find square centimeters? What does that mean? That means an area. Oops, I had that a little high. Hopefully you can see that again. So we're looking for a bunch of areas, and we're going to eventually find an A, the cost of the materials used to make the can as a function of the radius. So right now, that's far off because we don't even know what we're really dealing with. We only know that this cost is going to equal 2 cents times whatever our bottom and top are. I'm just going to write BT in orange here, bottom and top. And then that's added to 1 times whatever our vertical surface is. So I'm just going to write VS in blue. That's the only thing we know. So going off of that, we need to find areas because it's 2 times whatever the square centimeters are. So let's just look at the area of these top and bottom pieces. So the area of the bottom and top, the BT part. That shape is a circle, so we're looking for the area of a circle, which is area equals pi r squared. Okay, so that's going to go in right there. So 2 equals pi r squared. Okay, we're going to add that to the vertical surface. So remember from the one of the last problems, the vertical surface is really just a rectangle, and that rectangle is the height of our cylinder times this length right here really wraps around our cylinder. The wraparound part is the circumference. So this is the circumference. So when we're looking at this blue part, which is the vertical surface, that area is really our base, which is circumference, times the height. So circumference is 2 pi r, and then we're going to multiply that by height. But we're not really done yet because we need to have all of this in terms of r. But this equation right here has an h, so we have to figure out what we're going to do with that. Well, we were given an extra piece of information. We were given that the volume is 400 pi cubic centimeters. So let's look at volume. How do we find volume? And I'm going to go up here. Of a cylinder, well, it's the base times the height. Our base is a circle, so we're thinking pi r squared times our height. Volume, they told us, was 400. That's all equal to pi r squared times h. And we were just looking for h. So let's divide everything by pi r squared. So h is really going to equal 400 divided by pi r squared. So this h is really 400 divided by pi r squared. Simplifying that a little bit, we can multiply the 400 by 2, and we can cancel out these pi's because one's in the numerator, one's in the denominator. So we have 800 divided by r squared. Okay. So 800, and excuse me, I'm having a little bit of a debacle here in my head. So we want the vertical surface, so that is 800 over r squared, and that is being multiplied by 1 cent. Okay. And something's not setting right. I want a pi right here. So pardon my brain fart. Well, for the moment right now, we're going to just leave this go. And we're going to have 2 pi r squared plus 1 times 800 over r squared. And there should be a pi there. I'm just not seeing it right now. It just kind of flew away on me. But this is the cost in terms of radius. So there's a radius here and here. It's all going to give us the cost. The last thing we need to do is use a graphing calculator to find the minimum cost. So when you actually graph this, it's going to look like a parabola. And we're looking for when the cost is, what is the minimum cost? So you're looking for what is the y value right there. And when you put this equation into your calculator, it's going to give you 812. And that seems like a lot of money to make a can. But really, this is all done in cents, so this is really $8.12. So that's why it costs so much, or it looks like it's so much. So that one you use your graphing calculator for. Okay. Next, the water is flowing at a rate of 5 meters per second into a conical tank shown to the right. Shown, not showing to the right, shown. Find the volume of the water as a function of the water level H. So we're looking for volume as a function of H. So what does the volume of a cone look like? So the volume of a cone is 1/3 the base, which is pi r squared, times the height, which is h. And we want everything in terms of h. So we have an r right here, so we have to figure out what are we going to do with that r. We need to find out what does r equal. Well, we have this cone over here, which is very, very similar to a triangle. The last triangle problem that we dealt with was working with ratios. So we're going to see if we can work with ratios over here as well. This h is the height of the water. 120 meters is the height of the tank total. 60 meters is the diameter, or you can think about this as the radius is 30, which maybe will be better for us because we have an r here. So I want to think of everything in terms of r. So I'm going to think about the radius is 30 rather than the diameter 60. Okay? So if I want to set up a relationship, I can think about the relationship that, the radius of 30 is related in some way to the height of 120. So 30 over 120, that should be the same ratio as whatever the radius is down here, where the water actually is, over how high the water is. So we're looking at this ratio. And remember, we're looking for R. So we should find this in terms of R. In terms of H. So, I am all over the place right now. But these word problems, they're not the easiest thing in the book. So just give it some time. So we want to replace R with H's. So we need to find what R is in terms of H's. With that being said, I want to find then R. So get everything away from R. That just means multiplying by H. So 30 over 120 is really just 1/4 times H equals R. I'm then going to put that in for what I know R is into our original equation. So pi, and then this is H over 4 squared times H. So 1/3 pi H squared over 16 times H, which equals 1 times pi times H squared times H is really H cubed. And 3 times 16, that is 48. So the volume in terms of H is H cubed over 48. That was A. Now B, find H as a function of T. So I'm going to block off what I have here. So we want H in terms of T. What does that equal? Well, what other information do we have? We don't have anything with T's here. Nothing in this picture has a T in it. Nothing that we have written down so far has a T in it. We have to find something with a T. The original problem says water is flowing at a rate of 5 cubic meters per second. So the volume is going to be 5 cubic meters for every second that goes by. That's where the T comes in. So we're looking for H of T, but we don't have any H's in this equation. We have a T, but we have volume. So we need to get, instead of volume right here, we need to get H. Well, what is volume though? Well, we just found it over here. Volume is H cubed over 48. And that should equal 5T then. Okay? And I'm just going to pull another sheet of paper here since we need a little bit more room. So if H cubed over 48 equals 5T, and I want to know H of T, I want to find what H equals. So I'm going to multiply by 48 to the other side. So H cubed equals 5 times 48. So not a mental math thing. If you can't do it, it is actually just 240. You could think about this as 50 times 5, and then subtract 5 times 2 from that, because 48 is a difference of 2 from 50. That's one way to do it in your head. That's T. And then lastly, oops, I forgot a pi right here. Sorry, there should be pi H cubed there. So that is pi H cubed right here. And now I want to divide by pi. So H cubed equals 240 T divided by pi. And now to get H by itself, I'm going to take the cube root. So cubed root of all of this stuff. So 240 T over pi. So is H in terms of T now? Yes. So this is our final answer. Okay. All right, that was a tricky one, especially with that T coming into place. So whenever you get stuck, look back at your previous work, and then if that doesn't work, look back at the problem, because word problems have a lot of stuff in them. All right, this is our very, very last page. This is number 23 and 25. So as shown to the right, says 23, rectangle ABCD has vertices C and D on the x-axis and A and B on part of the parabola. So A and B, they're touching the parabola always. And that parabola is y equals 9 minus x squared. So we want to express P, the perimeter of the rectangle, as a function of the x coordinate of A. So we want the perimeter as a function of whatever this x value is right over here. So how do you get perimeter of a rectangle? Well, the perimeter of a rectangle, you're always going to take one side, find its length, and then times it by 2 for the other one. And then we're going to take the height of our rectangle and then times it by 2 to get the total side lengths, the total heights. So if we have 2 times our length plus 2 times our height, that's our perimeter. Well, what is the length? How do we find the length right here? Well, we know from here to here is x. That's a distance of x. And since this is symmetrical, that means this is also a distance of x. So the total distance is really just 2x. So the total length is 2x. The height, well, that's just 0 to y, the y coordinate. That's a distance of y. So what is y? Because we need everything in terms of x. So p equals 4x plus 2. We need to figure out what y is. Well, we know the equation is 9 minus x squared, and that's equal to y. So let's put that in. 9 minus x squared. So if we want to simplify that, p is equal to 4x plus 18 minus 2x squared. And that is our equation for the perimeter, because it is as a function of x, just like we wanted. And we can rearrange that so that the x squared comes first if we wanted to. But that is all we are asked to do in A. B, it asks for what is the domain of the function. So domain, remember, refers to all of our x values. So we want our x values. So let's pretend that our rectangle went all the way out to 3. If our rectangle went all the way out to 3, the height of our rectangle would be 0. So it can't reach 3 for that reason. So the width could never be 3. So the domain could never be more than 3. So no more than 3. If we think about how small we can get, well, we can't go negative, because if we were to go negative, our rectangle would have to cross over, and that doesn't really make any sense. So we're just looking at this side of the parabola, this side, this direction. So we can go up to positive 3, and then we can go down to, if we hit 0, the width would be 0, and then that's no longer a rectangle. But it could come pretty close to 0. So 0 is the lowest it could go. So no more than 3 and less than 0. So we would write that as x such that 0 is less than x, which is less than 3. So that is the domain. It has to go between 0 and 3, but it can't include those. And then it asks in C for what value of x is the perimeter of maximum. So for this, you would go ahead and use your calculator, typing in whatever this perimeter equation is. It's going to be a parabola, and it's asking you for what value of x is that going to have a maximum perimeter. So at that point, x, when you do it on your calculator, is going to equal 1. So that's going to give you the maximum perimeter for that case. Okay? So that one wasn't too bad when we actually had the picture with us. All right, the last problem, 25. From a raft 50 meters offshore, a lifeguard wants to swim to shore and run to a snack bar 100 meters down. So here's our raft. The lifeguard wants to swim to the shore and then run to the snack bar. In A, it's asking if the lifeguard swims at 1 meter per second and runs at 3 meters per second, express the total swimming and running time, t, as a function of the distance x, shown in the diagram. So we want our end goal to be t as a function of x. Well, how do we find time? That's a tricky one to think about. We could think about it like speed, because speed is related to time. Speed equals our distance over time. How far we traveled by how long it took us to get there. Think of miles per hour, meters per second, feet per second. So if we were just looking for time, that would equal our distance over our speed. So we're looking for our distance and also the speeds. Well, we have our speeds given to us where we swim, the lifeguard swims at 1 meter per second, and they run at 3 meters per second. But we want the total time. So that's two different equations we're looking at, because it's taking a different amount of time to swim than it is to run to the snack bar once you're finally on land. So t really equals two different, a combination of the distance over speed. So one distance over speed is for how long it takes us to get to the shore, and the other one is for how long it takes us to get from wherever we landed on the shore to the snack bar. So instead of making them new variables, I'm just going to write them in different colors. So the blue one is the swimming time, the orange is the running time. Alright, and we know that when we swim, our speed is 1 meter per second, and when we run, our speed is 3 meters per second. So all I need to find now is the distance that she needs to swim and the distance that she needs to run. Now remember, we want this in terms of x. So let's try to find first this distance that she has to swim in terms of x. Looking at this picture, we see it looks like a triangle. And we know that she's 50 meters out from shore. So that distance is perpendicular. Because that's perpendicular, we can use the Pythagorean theorem to find for whatever value this distance is. So we're looking for the blue distance right now, the swimming distance. And we're going to use a squared plus b squared equals c squared. We're looking for c squared. So we know 50 squared plus x squared has to equal d squared. So d squared, d really equals the square root of 2,500 plus x squared. 50 squared is 2,500. So this d right here, our blue d, our blue distance, our distance we're swimming, is really the square root of 2,500 plus x squared all over 1. Okay. Next, we need to find this distance that our lifeguard is running. So, the orange distance. Well, we know the lifeguard is 100 meters from the snack bar if they were on shore. So if we take 100, and we also know that the lifeguard is going to swim a distance of x on land. So if we want to find what this remaining distance is, we would take the total distance minus the distance that was already covered on the shore by how far our lifeguard was swimming. So that is going to equal our distance left that the lifeguard needs to run. So this is going to be added to our first time frame, so minus x, all over our speed, which was 3. Once the lifeguard got on land, they could run that fast. What were we asked to find again? The running, we were asked to express the total swimming and running time as a function of the distance x shown in the diagram. So did we have t as a function of x? Everything is as a function of x, so yes, we did do that. Now it asks us in B to use a graphing calculator to find the minimum time. If you were to type this into your graphing calculator, you would get out a parabola that looks like this. And it's asking for the minimum time. Time is a y value, so you're looking for whatever this value is, the y coordinate, at the lowest point of our parabola, and that time is 80.5 seconds about. So the shortest time it would take for this lifeguard to get from the raft to the snack bar would be 80.5 seconds. Whew, a lot to that one. Notice all these, they all have pictures. They all have two equations that we're working with, and it's all about solving for one variable and putting it back into the equation. So hopefully this helped with all the word problems.